Please welcome Petar and Vojislav. Petar is a site reliability engineer, and Vojislav is a software engineer and a technical excellence evangelist at United Cloud. They both will share how to unlock developer efficiency using internal developer platforms and Backstage. Please give a warm welcome for Petar and Vojislav.
Hello, I'm Vojislav. I'm Technical Excellence Evangelist for CI/CD at United Cloud.
And I'm Petar. I'm an SRE Engineer.
And today we are here to tell you about how we solved some inefficiencies in our scaling organization. First, for some context, about 6 years ago, we had 30 developers in 6 teams, all working on one project. Now we employ over 350 people in 32 teams, and we are working on 13 different products. So obviously, some things that used to work back then don't really work that well right now. So as I said, 6 years ago, we had 6 teams. Those 6 teams all used a different technology stack because we had one backend team, one streaming team, one client app team for each major platform, for web, iOS, Android, and for our set-top boxes. Our DevOps back then gave us Nexus and Jenkins, and each team was tasked to create their own build and deployment processes. And that was a good strategy for that time because each dev team knew their tech stack the best and they could do what works for them. Now, as our organization started to scale, as we had more and more teams, we basically standardized on those technologies. But there was no good communication between the teams, there was no code reuse between the teams, and every new team faced the same challenges that the previous teams already faced. And the issue is that they all solved those problems differently. So we basically had 3 or 4 ways to build and deploy a simple Java Spring Boot application, and that began to pose some problems. So we realized that we need to standardize the way that our software is developed, built, and deployed. Because we wanted to make sure that we have good practices baked in from the get-go, that we have high code quality, that we have high test coverage, good security practices implemented, and that our deployments are highly available. Another thing that happened is our transition from monolithic system to microservices. Because we realized that as number of teams grew, that our monolithic application does not scale well with the number of teams. So we started to make microservices. And in microservices world, the number of services that our teams develop and maintain started to grow exponentially. And that started to pose some problems again. Because it took about 1 day up to a week for a developer to get their new service running on testing environment, to have the continuous integration and delivery pipelines implemented and so on, because they had to set up a Git repository, webhooks, deploy tokens, Jenkins pipelines, Helm charts, and so on. So that really slowed down our development. Also, another problem with this is because it was so cumbersome process and painful and boring, developers would usually start working only on their laptops. So they would, let's say, start a new project, develop on their laptops for about a month, and after about a month of development, they would remember to open a DevOps request to get their development environment, to get their testing environment set up, so they could actually deploy their service and see how it's working. And then the DevOps team, based on their schedule, would either provide them with a testing environment right away, or maybe in a week or 2, even further delaying the first deployment to a testing environment. And that was really bad because you can see some problems can only be seen on a real production-like environment. Like, you cannot do a proper performance test on your laptop. You need production-like environment. There's some latency issues in inter-service calls. You can only see them on a real environment and not on localhost where your network is perfect, and so on. So in order to standardize the way our software is built and deployed, First, we created some templates. We created a sample application, how a sample application should look like. We created a sample pipeline, how our pipeline should look like, and how our Kubernetes deployment should look like. And next step was to convince developers that that is the way that they should work. And that was really a problem in some teams. Developers would usually say, yeah, the new templates, the new standards, they all look good. They're better than what we have now. But they already had something that works for them. So they did not really see incentive to switch the way they work because they already have something that works for them. Another thing that this did not solve is there was, again, no code reuse. Developers, we just created some templates how the things should look like, but developers, again, had to do all those steps manually. So in order to get adoption rate of this new standard, we realized that we will have to make this way the easiest way to work with in order for developers to embrace it. So in order to solve some of those issues, we started to build libraries instead of just templates. So we created libraries for our services, library for our Jenkins pipeline, and library for our Helm chart. So now when developers create a new service, they just include the common library, and they get their service integrated with our logging, monitoring, and alerting infrastructure. Also, they do not have to write their own Jenkins pipelines. We now have a library that has built and deploy jobs for each of our technology stacks. So now developer just has to call a pipeline. And if we, let's say, want to make some mass change in all of our pipelines, let's say add a new security analysis in all of our projects, we do that in just one place in our Jenkins shared library, and that step is implemented in all of our projects. Also, we realized that we have a lot of copy-paste in our Helm charts, basically, because we are basically developing simple web services most of the time, so our deployments look pretty much the same across all of our services. So we extracted all those things into a Helm chart. And we see that developers now actually also benefited this, that it made their life easier, and they wanted to use the new standard way of working. And what really helped us drive adoption of this new standard is Backstage. Because Backstage allowed us to automate all those boring and tedious repetitive tasks that nobody wants to do. And now when developers start a new service, they just fill up a simple form on Backstage. Backstage automates all those steps I mentioned before. And they get their new service ready to work with and deployed on testing environment with CI/CD in a matter of minutes instead of days or even weeks.
At United Cloud, we have several ideals we are striving for. The first is to have the independence of our teams, to be agile, to have declarative infrastructure, to have better discovery of our services, and to achieve self-service. We already have a strong DevOps as a culture implemented, and that covers the team independence. We use standard agile methodologies, and we also use trunk-based development to reduce integration and development cycles. That covers the agility. We use various in-house tools coupled with established tools such as Ansible and OpenTofu, and in that way we achieve a great deal of declarativeness in our infrastructure. In order to achieve greater discoverability and better self-service, we have turned to Backstage. From a DevOps and SRE point of view, I have a different kind of problems than developers. Since the number of microservices has exploded, it has become a detective work to find out things. For example, I oftentimes need information such as where are the monitoring dashboards associated with the service? And if I need to find out the deployment files, I need to search over 1,500 repositories in our Git and spanning over 100 Git organizations. Where is the repo I need? And where is the documentation? and heaven forbid if I have to go to Jenkins. And this constant reverse engineering to find out information is a great cognitive burden on both devs and developers. With Backstage, I have many of these questions answered at the tip of my fingers. Let's see the basic flow I can experience now when getting familiar with the new service. The first thing I see when I go to the Backstage is our inventory, a software catalog. When I click on a particular service, I can explore a bunch of metadata. The first thing I see is actually, oh, sorry, the slides are not. Slides keep going. The first thing I see in our inventory is a software catalog. When I click on a particular component, I can go straight to the source code for that service. Within the same view, I can also navigate to documentation. Sorry, the slides get skipping. Okay. I can also explore basic CI/CD and some metadata, and from there I can jump straight to Jenkins if I need to debug a pipeline. I can also view the APIs the service is providing or consuming, and I can also explore these APIs interactively. And I also have a Kubernetes tab where I can see the service deployed across all clusters and all namespaces. I can even explore individual pods, deployment manifests, pod manifests, and even view logs. There are also errors displayed in case there are any. When I get back to the main view, I have a links section. And in the links section, you can put anything, really. We usually put monitoring dashboards, so we can quickly jump to Grafana to see CPU usage and other relevant metrics. With relationship diagram, I can see resources associated with my component. For example, here is my service, and here are the APIs my service is providing. Here are the APIs my service is consuming and the infrastructure resources my service is using. You can notice visually that my service is using an S3 bucket, a database, and it is deployed on Kubernetes cluster. And it also uses the Git API. I can interactively explore all these elements. For example, I can click on the API, and I can see if there is any API within the organization which consumes this service. And I can even click on that service and explore it further. One of the interesting things is the owner. For example, if I click on the owner, I can see every resources within the organization which is associated with the owner. And if I go back to the component view and click on the owner in the relationship diagram, I can see the whole team, and I can choose who to contact if there is a need for more information. Since there are a lot of technologies that we are using, we try to make the best we can of the Tech Radar. Tech Radar comes out of the box with Backstage, and when I'm thinking about starting a new service or using a new tool or language, I can turn to Tech Radar to see which technologies we have adopted or are we currently assessing, or which technologies we put on hold or completely rejected. When I click on the language that interests me, I can see the complete history that led us from initial assessment all the way from trial to adoption. I even can put a link for relevant information, for example, to get on board with the relevant technology. With this rich metadata provided through the software catalog, we give our developers an easy way to discover resources within the organization, such as repositories, documentation, infrastructure resources. Now let's turn to the last requirement we wanted to achieve. The second set of problems I have is automating tedious tasks. DevOps teams are always struggling with a lot of operational toil, especially with all the boilerplate that comes when creating a new service. For example, when we make a new service, we need to make a new Kubernetes namespace. We need to make proper roles, permissions, service account, make service account token, distribute those service account tokens, for example, to enable communication between Jenkins and Git, and so on. We may need to make and configure a new Harbor project. We may need to make a new Git organization, or even SonarQube permission templates. This is a lot of manual labor, but with Backstage, we can automate it. Since we already have a strong culture as a self-service, realized primarily through self-service repositories, the first thing we did was to tie all of our existing self-service repositories into a single view. We strive to use Backstage as an aggregator of our existing tooling rather than replacement. Templates are something that can be built by any team. And even SRE and DevOps have a lot of need for templates, for example, for Python or Golang, for services we are building for automation. Let's see how a service is actually made from the template. The first thing I would do is to select the proper template, fill in the form. I can use drop-downs to select Git the organization, Harbor project, Jenkins folder, and so on. After the form is completed, template actions kick in and actually make the Git repository, push project files, make pipelines, make Git webhooks, and then standard CI/CD kicks in and deploys this to Kubernetes. You can then go to Software Catalog Kubernetes tab and see the deployment status for your service. By tying our existing self-service repositories and making them available through Backstage, and by adding Software Catalog, we have achieved better self-service for the teams. Since we've seen a lot of pros, what are the challenges we faced when building this platform? Since both DevOps and developers had a similar set of problems, we needed to approach these problems from two different angles. Backstage proved to be a good common ground to join forces. Therefore, we needed at least 2 people to realize this project. Vojislav worked on template automation, and I worked on integrating Backstage with various services. In total, we needed around 6 months for planning and development. We have to keep in mind that Backstage is a framework. It's not a ready-made solution. There are a lot of ready-made solutions for IDPs, but they all come with a hefty price. We strongly lean on open source, so we wanted something that is extensible and can be integrated with various tools we use in our house. For example, Backstage has very limited integration with Git, so we had to write our own integration. If you are using GitLab or GitHub, you can cut the development time, of course. But Backstage also requires a skillful team that has the knowledge of front-end, back-end, and a basic understanding of infrastructure tooling. We also had to write a lot of plugins for Backstage. In addition to third-party plugins we are using, we wrote 11 custom plugins. We wanted our developers to have a nice drop-down menus to choose folder for Jenkins when making a new service. That's a plugin. We needed a template action to actually push templated files to Git. That's another plugin, and so on. Once we implemented the Backstage, there came the problem of maintenance. Upgrading to a new version is same as upgrading any code base to the most recent libraries. Parts of the code need to be changed, need to be rewritten or refactored. Dependencies may break your custom integrations, and some libraries may be out of date, holding the upgrade altogether. We have a steady update pace of once in several months, and luckily there is a detailed upgrade guide provided by the Backstage itself. To overcome all these challenges, we need to have constant feedback from developers. We need to treat developers as customers, and we need to treat IDP as we treat any product within the organization. Because of all of this, an organization usually needs to have some size to it and some level of maturity. Sometimes there are dedicated developer experience teams. For us, we are at a moment in the organization history where we need to standardize our tech stack, automate operational toil to free DevOps and developers from wasting time on boilerplate, and where we have enough skills to develop and maintain Backstage. Finally, we still have some open-ended questions and a lot of ideas for future development. Enriching our self-service menu is an obvious one, but we also want to implement more metrics. For example, mean time to PR, the adoption rate, and so on. We want to have better mapping of our infrastructure to our microservices, databases, caches, etc. We also want to automatically ingest all our existing and all new repositories into the Backstage and onboard the whole organization. At United Cloud, on the inception of the service, we have various service deployment procedures, SDPs, which ensure that all teams are on board and all best practices have been followed. There are SDPs for various teams, for example, SRE SDP, InfoSec SDP, and so on. And the SRE SDP answers questions such as, is this service highly available? What are the storage needs for this service? Are database migrations automated? At the moment, the review process is manual, but with Backstage, we want to automate this through templates. We will be having shortly, I think it's 28th of November, yeah, meetup, so you can scan the QR code for more information, and we have time for Q&A now. Thank you. Are there any questions?
Thank you, folks. Any questions? Please feel free to raise the hand and you'll get a mic. If not, let's just check if there's something in the Whova app. We have one in the Whova app. So it says, how did you decide the boundaries or size of microservices?
Well, I don't think that's really the question for this talk. But to give some answer, we do not want our microservices to be nanoservices. We don't really want them too small. So we started to extract from our monolithic system big parts of our domain that makes sense to be a standalone service. We do not try to make, if we have some new feature to add, we will consider either adding it to our existing monolith, or if we see that it's part of some other domain, we will maybe extract something more from the monolithic system and then implement a new feature on top of that. But yeah, not really the topic.
Thank you. Any more questions? Oh, we have one here. Yeah, you'll get a mic soon.
Thank you. Great talk. I just have one question. As part of self-service that you were talking about, did you guys implement some auditing for cost monitoring? If, as a developer, as a team, I can just span up services with no control from above, is there something that you are monitoring in that case or no?
No, at the moment we don't have a solution to monitor the costs, but the extent to which we implemented Backstage at the moment is contained to templates only. So we plan to implement more, but we also have in backlog for cost control and cost monitoring.
All right, thank you.
Got it. We have one more for the Whova app. It says, what alternatives to Backstage were you considering to use?
There is Port, but it's like $25 or $30 per user. And there are a couple more, so I don't remember the names. The Backstage is, the advantage is that it's a framework. And we have a lot of custom tools and a lot of, for example, Nexus instead of Artifactory, and we use Git instead of GitHub. So the easiest integration was to start from scratch, but not totally from scratch to write our own IDP. So that's when we decided to use Backstage.
Thank you. And there's one more. How do you cover non-B software, mobile/embedded desktop? Does that make sense?
Yeah.
Non-B. Igor asked that question.
Not backend. Yeah, we have also templates for. I mean, this is not only for backend. Right now, we are using mostly for backend. We have for our JavaScript, for our Vue.js JavaScript applications, another template. It goes through this. Those are the things that made the most sense to start with, because those are the things that we are creating the most. We have like one, or we have few Android applications, and we don't create those every day. But yeah, they can absolutely be imported here, and they will be imported. But for creating new ones, we just did not see benefits enough to start with them at the start.
And one more, do you monitor your pipelines?
Do we monitor our pipelines? Yes, we do. We made a custom solution using, using OpenSearch and just scraping. We are scraping our Git repositories, we are scraping our statuses and our Jenkins pipelines, and our deployments. We are all aggregating them into OpenSearch, and we are monitoring them using OpenSearch dashboards. So yeah.
Great, thank you. We have one more. Have you done any benchmarks that show how implementing Backstage has improved developer experience?
The problem with that is that we did not have basically any previous measurements before implementing Backstage, but as a developer, as someone who spent a few years in developer teams and starting new projects, I knew that this really could take up to a week to just set up every little detail to get your CI/CD working, to get your repositories up to standard, your deployments up to standard, and it was really a tedious task. So this definitely helped a lot. Do not hear metrics.
Yeah, your previous answer might partially answer this question. How hard was it to integrate Backstage with all existing infra?
It was challenging because it's a framework. It comes with a lot of third-party plugins, but the greatest challenge was integration with Gitty. We migrated from GitLab to Gitty a year ago or a couple of years ago, and the existing integration is half done in Backstage. So everything that was of importance to us needed to be rewritten from scratch. It has some development time. People need to know TypeScript, need to know React, need to know Node.js. So with a skillful person, the integrations can more or less be painless, but the documentation is the problem. The code is not so challenging as the documentation, the lack of documentation in Backstage.
Cool, thanks. Any more questions? We have some more time left. Going once, twice. Okay. Here, no? All right. Thank you, guys.
Thank you.